Hello, in this lecture we find out the length of line segment X. In the drawing we have a circle that is inside rectangle ABCD. We know that the length of the tangent from point A to the circle is 33 units. The length of the tangent from point B to the circle is 85 units. The length of tangent from point D, or the tangent from point D to the circle is 35 units, and we want to find out the length of the tangent from point C to the circle, that is defined as x. So first of all, we define the center of this circle as O. We'll define the point of tendency of the tangent from point D to the circle as point E. We define the point of tendency of the tangent from point A to the circle as point F. We define the point of tendency of the tangent from point B to the circle as point T, and we define the point of tendency of the tangent from point C to the circle as point L. Here we are looking for the length of tangent CL that is equal to x. In the next step, we will join points O and E together by a straight line. Point O is the center of the circle. Point E is the point of the circle itself, therefore OE is the radius of the circle that we define as R. We have the radius OE that is drawn to the point of tendency. According to rule number 1, the tangent to a circle is perpendicular to the radius drawn to its point of tendency. Here we have tangent AB that is tangent to the circle at point M. And according to rule number 1, because of the fact that the radius OM it is drawn to the point of tendency, that is to say to point M, then tangent AB will be perpendicular to the radius MO. That is to say this angle will be equal to 90 degrees and this angle will be equal to 90 degrees according to this rule, rule number 1. So here we have the radius OE that is drawn to the point of tendency, therefore according to rule number 1, this angle will be equal to 90 degrees. Okay. We join points O and F together by a straight line. Point O is the center of the circle, point F is the point of the circle itself, therefore OF is the radius of this circle that is equal to R. And we have the radius OF that is drawn to the point of tendency, therefore this angle will be equal to 90 degrees according to rule number 1. Likewise, we join points O and T together by a straight line. Again, point O is the center of the circle, point T is the point of the circle itself, therefore OT is the radius of the circle that is equal to R, and we have the radius OT that is drawn to the point of tendency, therefore according to rule number 1, this angle be equal to 90 degrees. And finally, we join points O and L together by a straight line. Point O is the center of the circle, point L is the point of the circle itself, therefore OL is the radius of this circle that is equal to R. And we have the radius OL that is drawn to the point of tendency, therefore according to rule number 1, this angle equals to 90 degrees. Okay. The next step, we will join points A and O together by a straight line. We'll focus on the right triangle, triangle AFO. In the right triangle, triangle AFO, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AF squared plus FO squared equals to AO squared. AF equals to 33, therefore AF squared is 33 squared plus FO squared. FO equals to R, therefore FO squared equals to R squared and is equal to AO squared. So in conclusion, found out that according to equation number 1, (33 squared plus R squared) equals to AO squared. In the next step, we join points B and O together by a straight line. And we'll focus on triangle BTO. This right triangle, this right triangle, triangle BTO, according to the Pythagoras theorem, BT squared plus TO squared equals to BO squared. Repeat again, in the right triangle, triangle BTO, according to the Pythagoras theorem, BT squared plus TO squared equals to BO squared. BT equals to 85 units, therefore BT squared is 85 squared plus TO squared. TO equals to R, therefore TO squared is R squared, is equal to BO squared. So in conclusion, according to equation number 2, found out that 85 squared plus r squared equals to bo squared. In the next step, we join points C and O together by a straight line. So here we created triangle L, the right triangle, triangle LOC. To focus on the right triangle, triangle LOC, according to the Pythagoras theorem, LO squared plus LC squared equals to CO squared. Repeat again. In the right triangle, triangle LOC, LO squared plus LC squared equals to CO squared. LO equals to R, therefore LO squared equals to R squared plus LC squared. LC equals to X, therefore LC squared is X squared. That is equal to CO squared. So in conclusion, according to equation number 3, we found out that R squared plus X squared equals to CO squared. In the next step, we will join points O and D together by a straight line. And we will implement the Pythagoras theorem on the right triangle, triangle EOD. In the right triangle, triangle EOD, this right triangle, we will get that EO squared plus DE squared equals to DO squared. I repeat again. In the right triangle, triangle OED, this right triangle, according to the Pythagoras theorem, we get that EO squared plus DE squared equals to DO squared. So EO equals to R, therefore EO squared is R squared plus DE squared. DE equals to 35, therefore DE squared is 35 squared, and it is equal to DO squared. In conclusion, we found out that according to equation number 4, R squared plus 35 squared equals to DO squared. So I will copy the 4 equations here. According to equation number 1, 33 square plus r square equals to AO square. According to equation number 2, 85 square plus r square equals to BO square. According to equation number 3, r square plus x square equals to CO square. And finally, according to equation number 4, we found out that r square plus 35 square equals to DO square. Okay. In the next step, I will copy rectangle ABCD in a new page and also the rectangle with the circle, and we will analyze rectangle ABCD. We will do a construction. So we have rectangle ABCD. Inside rectangle ABCD, we have a circle So this is rectangle ABCD with the circle inside it. We know that all the angles inside a rectangle are right angles, so those 4 angles are all right angles. So in the next step, we do a construction from the center of the circle. We draw perpendicular on AD. So here, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from the center of the circle, that is to say from point O and AD is T, because of the fact that in rectangle the opposite sides are parallel to each other. That is to say, side AB is parallel to side BC. It means that the perpendicular from point O to AD will be also perpendicular to BC because of the fact that AD is parallel to BC. Therefore, here we'll also have here the perpendicular to AD will be perpendicular to BC also. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees according to our construction. I repeat again, the perpendicular to AD that we drew will be also perpendicular to BC because of the fact that AD is parallel to BC. We define the touching point of the perpendicular from point O and BC as M. In the next step, from point O, we draw perpendicular on AB. So here, this angle will be equal to 90 degrees and this angle will be equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AB as N, and because of the fact that side AB is parallel to side DC, it means that the perpendicular from point O to AB will be also perpendicular to DC. Again, the perpendicular from point O to AB will be also perpendicular to DC. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and DC as S. So here, inside quadrilateral ANTO, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. Therefore, the fourth angle here must be also equal to 90 degrees. Because 270 degrees plus 90 degrees, it is 360 degrees. That is the sum of the angles in any quadrilateral. Likewise, in quadrilateral TODS, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. Therefore, the fourth angle must be also equal to 90 degrees. And exactly for the same reason, inside quadrilateral NBMO, we have 1, 2, 3 right angles. Therefore, the fourth angle here must be also equal to 90 degrees according to the same rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Likewise, in quadrilateral OMSC, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees according to the same rule. So actually, we have here, we created here 4 rectangles. We have here 4 rectangles, and we know that the opposite sides of a rectangle are equal to each other. So here we define side AT of rectangle ANTO as edge 1. We define side TD of rectangle TODS as edge 2. We define side AN of rectangle ANTO as B1, and we define side NB of rectangle NBOM as B2. I'll repeat again, according to the rule that the opposite sides of a rectangle are equal to each other. So if we focus on rectangle ANTO, this rectangle, side AN equals to B1, side AN equals to B1. AN equals to B1, therefore TO must be also equal to B1 because of the fact that the opposite side AN of rectangle AN TO is equal to the opposite side TO. So if AN equals to B1, then TO must be also equal to B1. Likewise, in rectangle TODS, side TO must be equal to side DS. But TO equals to B1, therefore DS must be also equal to B1. Likewise, in rectangle ANTO, side AT equals to H1, therefore side NO must be also equal to H1 according to the same rule that the opposite sides of a rectangle are equal to each other. Likewise, in rectangle TODS, this rectangle, side TD equals to side OS, but side TD equals to H2, therefore side OS must be also equal to H2. Likewise, in rectangle NOMB, side NB equals to side OM. NB equals to OM. But NB equals to B2, therefore OM must be also equal to B2. And in rectangle OMSC, side OM equals to side SC. But side OM equals to B2, therefore side SC must be also equal to B2. And finally, in rectangle NBOM, side NO equals to side BM. But side NO equals to H1, therefore side BM must be also equal to H1. Okay? So, in the next step, we'll join points A and O together by a straight line. So, in triangle, the right triangle ANO, according to the Pythagoras theorem, we get that B1 square plus H1 square equals to AO square. Repeat again. In the right triangle ANO, B1 square plus H1 square equals to AO square. According to the Pythagoras theorem, of course. I'll repeat again, in the right triangle ANO, according to the Pythagoras theorem, B1 square plus H1 square equals to AO square. Likewise, we join points O and B together by a straight line. And we will focus on the right triangle NBO. This right triangle, according to the Pythagoras theorem, in this right triangle, B2 square plus H1 square equals to OB square. B2 square plus H1 square equals to BO square. Repeat again, in the right triangle NOB, this right triangle, we get that according to the Pythagoras theorem, B2 square plus H1 square equals to BO square. Likewise, we join points O and C together by a straight line. And we'll focus on the right triangle, triangle OMC. The right triangle OMC, according to the Pythagoras theorem. Here, before I continue, in rectangle OMSC, in this rectangle, the opposite sides are equal to each other. That is to say, side OS equals to side MC. But OS equals to H2, therefore MC will be also equal to H2. So in the right triangle, triangle OMC, B2 square plus H2 square equals to CO square. B2 square plus H2 square equals to CO square. So I write it down. B2 square plus H2 square equals to CO square. So in the right triangle, triangle COM, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. We get that B2 square plus H2 square equals to CO square. And finally, we'll join points D and O together by a straight line. And we focus on the right triangle, triangle OTD. In this right triangle, according to the Pythagoras theorem, we get that B1 square plus H2 square equals to DO square. Again, according to the Pythagoras theorem, in the right triangle OTD, B1 square plus H2 square equals to DO square. Repeat again, in the right triangle TOD, this right triangle, according to the Pythagoras theorem, we get that B1 square plus H2 square equals to DO square. Okay, so we have here 8 equations. In the next step, we create equation number 1 that states that AO square in this equation equals to AO square in this equation. BO square in this equation must be equal to BO square in this equation. CO square in this equation must be equal to CO square in this equation. And finally, DO square in this equation must be equal to DO square in this equation. Okay, so here we have equation number 1. According to equation number 1, AO square in this equation must be equal to AO square in this equation. That is to say, AO square in this equation is 33 square plus R square, and it must be equal to AO square in this equation. That is actually it is B1 square plus H1 square. So this equation states that AO square in this equation equals to AO square in this equation. Likewise, BO square in this equation must be equal to BO square in this equation. This will be equation number 2. So BO square in this equation is 85 square plus R square. And it must be equal to B2 square plus H1 square. Likewise, you create the further equation that states that CO squared according to this equation must be equal to CO squared according to this equation. So equation number 3 states that CO squared according to this equation, R squared plus x, it is equal to R squared plus x squared, and it must be equal to CO squared according to this equation, that is actually B2 squared plus H2 squared. And finally, we create the fourth equation that states that DO squared according to this equation must be equal to DO squared according to this equation. DO squared according to this equation is R squared plus 35 squared. And it must be equal to DO squared according to this equation, that is P1 squared plus H2 squared. So here we have the 4 equations. In the next step, we'll subtract equation number 2 from equation number 1. We subtract equation number 2 from equation number 1, and we get that equation number 2 is 85 squared plus R squared minus equation number 1, that is 33 squared plus R squared, and it is equal, we subtract the other side of the equation number 1 from equation number 2, and you will get that it is actually equals to B2 squared plus H1 squared minus B1 squared plus H1 squared. So this will be equation number 5. Here we'll open the brackets of this equation, equation number 5, and we get that according to equation number 5, 85 squared plus R squared. We'll open the brackets here. We'll minus before the bracket, so here it will be negative. So it will be minus 33 squared minus R squared, that is equal to B2 squared plus H1 squared. We open the brackets here. So here we have minus before the bracket, so here it will become minus B1 squared minus H1 squared. Okay, so here R squared minus R squared is 0, so R squared gets cancelled. And here H1 squared minus H1 squared is 0. So what is left from equation number 5 after we cancelled the 2 expressions here? In this side of the equation we left only if 85 squared minus 33 squared, that is equal to B2 squared minus B1 squared. Okay. In the next step, we subtract equation number 4 from equation number 3. Okay. We subtract equation number 4 from equation number 3, and we get that in this way we create equation number 6. So according to equation number 6, we get that r squared plus 35 squared minus r squared plus x squared equals to b1 squared plus h2 squared minus b2 squared plus h2 squared. Next step, we will open the brackets of this equation, equation number 6, and we get that according to equation number 6, r squared plus 35 squared, we have minus before the bracket, so here it will become minus r squared minus x squared, that is equal to b1 squared plus h2 squared. We have minus before the bracket, so it will be b2 squared minus h2 squared. Okay. So here r squared minus r squared is 0. And we have here h2 squared minus h2 squared is 0. So what is left after we cancel the two expressions here? For equation number 6, in this side of the equation we left only with 35 squared minus x squared, that is equal to b1 squared minus b2 squared. So here we will multiply this equation, equation number 6, by minus 1, and we get that according to equation number 6, b2 squared minus b1 squared equals to x squared minus 35 squared. So in equation number 6 we have b2 squared minus b1 squared, and in equation number 5 we have also b2 squared minus b1 squared. So b2 squared minus b1 squared in equation number 5 must be equal to b2 squared minus b1 squared in equation number 6. This way we create equation number 7 that states that b2 squared minus b1 squared according to equation number 5, that is actually 85 squared minus 33 squared, must be equal to b2 squared minus b1 squared according to equation number 6, that is actually x squared minus 35 squared. Okay, so here we will add 35 squared to this equation, equation number 7, and we get that according to equation number 7, x squared equals to 85 squared plus 35 square minus 33 square. Repeat again. Found out that according to equation number 7, x square equals to 85 square plus 35 square minus 33 square. That is to say, x square equals to 85 square is 7,225 plus 35 square is 1,225 minus 33 square is 1,089. So in conclusion, found out that according to equation number 7, x square equals to 7,225 plus 1,200 is actually 35 square is 1,225 plus 7,225, it will be equal to 8,450 minus 1,089. So in conclusion, we get that x squared equals to 7,361. So here we take a root out of this equation, equation number 7, and we get that x equals to plus minus the square root of 7,361. So here we have two solutions for x. The first one is negative solution, the second is the positive solution. But because of the fact that ax is the length of line segment CL, so x as a length, x as a length, it must be a positive number. Therefore, the only solution that is possible here is that x equals to the positive root of 7,361, that is actually equals to the square root of 7,361 equals to plus 85.796 units. So the answer to the question is that the length of this line segment LC that is equal to x is equal to 85.796 units. So we finished with the question. In the next step I will summarize the lecture. So in the drawing we have a circle inside rectangle ABCD. Okay. We know that the tangent from point A to the circle is equal to 33 units. The tangent from point B to the circle is equal to 85 units in its length. The tangent from point C to the circle is the tangent that we are looking for, tangent X. And finally, the tangent from point D to this circle is equal to 83 units in its length. And again, our mission is to find out the length of tangent CL that is equal to X. Okay, so first of all, we defined the center of this circle as O. From point O, we joined point O and F together by a straight line. Point O is the center of the circle, point F is the point of the circle itself, therefore OF is the radius of the circle that we defined as R. And we have the radius OF that is drawn to the point of tendency, therefore according to rule number 1, this angle equals to 90 degrees. Okay, so here we created actually the right triangle, triangle AOF. In this right triangle, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AO square plus OF square equals to FA square. Again, AF square plus FO square, AF square plus FO square equals to AO square. Here AO is the hypotenuse. So I repeat again, according to the Pythagoras theorem, on the right triangle, triangle AOF, AF square plus FO square equals to AO square. AF equals to 33, therefore we substitute AF by 33, therefore AF square is 33 square plus OF square. OF equals to R, therefore OF square is R square plus AO square. AO is the hypotenuse, so in conclusion we found out that 33 square equals to R square plus AO square. Likewise, we joined points O and T together by a straight line. Point O is the center of the circle, point T is the point of the circle itself, therefore OT is the radius of this circle. And we have the radius OT that is drawn to the point of tendency, therefore according to rule number 1, this angle equals 90 degrees. Then we joined points B and O together by a straight line. In this way we created the right triangle, triangle BTO. And then we implemented the Pythagoras theorem on the right triangle, triangle BTO. According to the Pythagoras theorem, OT square plus BT square equals to OB square. Repeat again. The right triangle BTO, according to the Pythagoras theorem, we get that BT square plus TO square equals to BO square. BT equals to R, therefore BT square is R square plus TB square. TB equals to 85, therefore TB square is 85 square, and it is equal to the square of the hypotenuse, that is OB square. So in conclusion, we found out that according to equation number 2, 85 square plus R square equals to BO square. Then we joined points O and actually we join points O and L together by a straight line. Point O is the center of the circle, point L is the point of the circle itself, therefore OL is the radius of the circle that is equal to R. We have the radius of OL that is drawn to the point of tendency, therefore this angle equals to 90 degrees according to rule number 1. Then we implemented the Pythagoras theorem on the right triangle, triangle COL. According to the Pythagoras theorem, CL square plus LO square equals to OC square. Okay, again, according to the Pythagoras theorem, LO square plus LC square equals to CO square. LO equals to R, therefore LO square is R square plus LC square. LC equals to X, therefore LC square is X square, and it is equal to CO square. So in conclusion, we found out that according to equation number 3, R square plus X square equals to CO square. And finally, we joined points O and E together by a straight line. Point O is the center of the circle, point E is the point of the circle itself, therefore OE is the radius of this circle that is equal to R. OE equals to R, and we have the radius OE that is drawn to the point of tendency, therefore according to rule number 1, this angle equals to 90 degrees. Then we joined points O and D together by a straight line. In this way, we created the right triangle, triangle DEO. In the right triangle, triangle DEO, DE square plus EO square equals to OD square. Repeat again. ED square plus DE square equals to DO square according to the Pythagoras theorem. EO equals to R, therefore EO square is R square plus ED square. ED equals to 35, therefore ED square is 35 square. So in conclusion, we found out that R square plus 35 square equals to DO square. So I created here 4 equations. So I copied the 4 equations that we created in this column, and then actually draw rectangle ABC D in this new page, and the circle is inside rectangle ABCD. We know that all the angles inside the rectangle are right angles. Those 4 angles are all right angles, and then from the center of the circle, that is to say from point O, we go perpendicular on AB. So this angle equals 90 degrees and this angle equals 90 degrees according to our construction. But because of the fact that in rectangle ABCD, side AD is parallel to side BC, the perpendicular that we draw on AD must be also perpendicular on BC again, because of the fact that BC is parallel to AD. So this angle equals to 90 degrees and this angle must be also equal to 90 degrees according to our construction. Likewise, from the center of this circle, that is to say from point O, we go perpendicular on AB. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. But because of the fact that side AB in rectangle ABCD is parallel to side DC, the perpendicular on AB will be also parallel to, will be also perpendicular to DC. Why? Because AB is parallel to DC, therefore the perpendicular on AB will be also perpendicular to DC. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. So in quadrangle ANTO we have 1, 2 right angles, therefore the fourth angle must be also equal to 90 degrees. In quadrangle TODS we have 1, 2 right angles, therefore the fourth angle must be also equal to 90 degrees. In quadrangle NOBM we have 2 right angles, therefore the fourth angle must be also equal to 90 degrees. And finally, quadrangle OMCS, we have 2 right angles, therefore the fourth angle must be also equal to 90 degrees. We actually created here 4 rectangles. Okay, and we know that the opposite sides of a rectangle are equal to each other. So we define side AT as edge 1, we define side TD as edge 2, and we define side AN as B1 and side NB as B2. So in rectangle ANTD, the opposite sides are equal to each other. So side AT equals to edge 1, therefore side NO must be also equal to edge 1. Likewise, in rectangle ANOT, side AN equals to B1, therefore side TO must be also equal to B1. Likewise, in rectangle TODS, side TO equals to B1, therefore side DS must be also equal to B1. Side TD equals to H2, therefore side DS must be also equal to H2. Likewise, in rectangle NOMB, this rectangle, side NB equals to B2, therefore side OM must be also equal to B2. And NO equals to H1 in this rectangle, therefore BM must be also equal to H1. And finally, in rectangle OMSC, side DS equals to H2, therefore side MC must be also equal to H2. And finally, side DM equals to B2, therefore side SC must be also equal to B2. Okay, and then we join points A and O together by a straight line. So in triangle ANO, according to the Pythagoras theorem, B1 square plus H1 square equals to AO square. Again, B1 square plus H1 square equals to AO square. I repeat again. In triangle ANO, B1 square plus H1 square equals to AO square. Likewise, in triangle, the right triangle, triangle N, we join points O and B together by a straight line. So in the right triangle, triangle NOB, B2 square plus H1 square equals to BO square. I repeat again. In the right triangle, triangle NOB, B2 square plus H1 square equals to BO square. Likewise, we joined points here O and C together by a straight line. So in triangle OSC, this right triangle, H2 square plus B2 square must be equal to OC square. B2 square plus H2 square must be equal to CO square. And finally, we join points O and D together by a straight line. So in the right triangle OSD, H2 square plus B1 square must be equal to DO square. I repeat again. In the right triangle, triangle OSD, B1 square plus H2 square equals to DO square. Okay, then, so we have 8 equations here. We have 2 equations for AO square, 2 equations for BO square, 2 equations for CO square, and 2 equations for DO square. Therefore, we can write down that AO square according to equation number 1 must be equal to AO square according to equation number AO square according to this equation must be equal to AO square according to this equation. Here BO square according to this equation must be equal to BO square according to this equation. Here CO square according to this equation must be equal to CO square according to this equation. And finally, DO square according to this equation must be equal to DO square according to this equation. Okay, so in this way, we actually created 4 equations. Okay, here AO square according to the first equation must be equal to AO square according to the second equation. BO square according to the first equation must be equal to BO square according to the second equation. CO square according to the first equation must be equal to CO square according to the second equation. And finally, DO square according to the first equation must be equal to DO square according to the second equation. Okay, so we can end in this way those four equations, and then we subtracted equation number 2 from equation number 1. That is to say, here equation number 2 is 85 square plus r square, minus equation number 1 that is 33 square plus r square. So we subtracted this side, and then we subtracted the other side of equation number 2 from equation number 1. Equation number 2, in this side we have b2 square plus h1 square, minus equation number 1 is b1 square plus h1 square. Then we open the brackets here, we have minus before the bracket, so it will become minus here, minus 33 square minus r square. And we have here b2 square plus h1 square, we open the brackets here. So here we have minus before the bracket, so it will become minus b1 square minus h1 square. R square minus r square is 0, h1 square minus h1 square is 0, so in total, what is left on equation number 1 after we cancel those two expressions, what is left is, in this side of the equation, we left only with 85 square minus 33 square, that is equal to b2 square minus b1 square. Then we subtracted equation number 4 from equation number 3. Only to equation number 4, we have here r square plus 35 square minus equation number 3, that is r square plus x square. And then we subtracted the other side of equation number 4 from equation number 3. In the other side of the equation number 4, we have b2 square plus h2 square minus equation number 3, that is b2 square plus h2 square. Then we open the brackets here, and we have r square plus 35 square, we open the brackets here, and we have minus before the bracket, so it will become minus r square minus x square, that is equal to b1 square plus h2 square. We open the brackets here, so we have minus before the bracket, so it will become minus h2 square minus h2 square minus here we have actually minus b2 square minus h2 square. R square minus r square is 0, and here minus h2 square minus h2 square is 0. So what is left from equation number 6 after we cancelled the two expressions? In this side of the equation we left only 35 square minus x square. In the other side of the equation number 6 we have b2 square minus b1 square. Then we multiply the equation number 6 by minus 1, and we found out that according to equation number 6, b2 square minus b1 square equals to x square minus 35 square. Then b2 square minus b1 square according to equation number 5 must be equal to b2 square minus b1 square according to equation number 6. In this way we can get equation number 7. So b2 square minus b1 square according to equation number 5 is 85 square minus 33 square, and it must be equal to b2 square minus b1 square according to equation number 6, that is x square minus 35 square. Here we added 35 square to this equation number 7, and found out that according to equation number 7, x square equals to 85 square plus 35 square minus 33 square. So x square equals to 85 square is 7,225 plus 35 square. 35 square is 1225 minus 33 squared. 33 squared is 1089. So x squared equals to 7225 plus 1225 is 8450 minus 1089 is 7361. So we found out that according to equation number 7, x squared equals to 7361. We took a root out of this equation, equation number 7, and found out that x equals to plus minus the square root of 7361. But because of the fact that x is a length, it must be a positive number. So the only answer that is possible for x is the positive root of 7361. That is actually the positive square root of 7361 is 85.769 units. So we found out that the length of this line segment X, the length of line segment X here, the length of this line segment X, it is equal to 85.796 units. Again, line segment LC that is equal to X, it is equal to 85.796 units. Okay, thank you very much.